Good morning, everyone. Today we are going to look about JK flip-flop. Still, we have to think about what is a flip-flop. Flip-flop in a digital electronics, it's a circuit with a two stable state that can be used for stored data, binary data. The stored data can be changed by applying varying inputs. Okay, so the flip-flop are basically large and fundamental block diagram of a digital electronic system used in a computer communication and other type of system. Both are used as a storage element. Basically, we know that in the binary system we have only ones and zeros. So one will represent high and zero will represent the low. Okay, so if the flip flop we are giving the information whether high or low based on that output will raise. There are basically if for the flip flop considering a flip flop or D flip flop or Jacob flip flop or master slave flip flop or T flip flop, all of the type of a flip flop based on that input states will be different. Basically, we're considering a flip flop is a device that have an two inputs, and based on that, there will be a clock pulse. Okay, so we'll have a two inputs, and there will be a clock pulse. Clock pulses maybe we can divide it into edge trigger clock pulses. So that's our positive edge trigger and negative edge trigger. If I'm going for a positive edge trigger, that means that the value varying from 0 to 1, it will consider as a uh, variation from positive edge trigger. From 1 to 0, it is considered as a negative edge trigger. Okay, so it was a JK flip flop, the diagram of the JK flip flop. You can see that here J is the input and the K is another input, and you have a clock pulses. So based on the J and K, output comes and output will rise. J If J is 1 and K is 0, output Q is 1, Q complement is 0. If J is 0, K is 1, in that case Q is 0 and Q complement is 1. These inputs are these are the inputs. J and K are the inputs. Clock pulses either positive edge trigger or negative edge trigger. Based on the edge trigger, the output will rise. Okay, so if you consider J and K both are 1 1, that's a condition. But in this condition in the SR flip-flop, it is called as a forbidden condition or undefined condition or raise around condition. So these two words we mostly use. But that means that if both inputs are high, the output Q and Q complement, it become in a raise condition. Okay. It's in a raise condition. That means that Q1 time become one and Q complement is then in the next it becomes shifting. Okay, so we can't predict that which output is high. So basically, we say that if SR flip-flop is you're using, and if S is 1 and R is 1, then output in a raise condition. It is basically we call that undefined state, otherwise a forbidden condition. You're not supposed to use that condition in that case. And other one cases is there like S is equal to 0, R is equal to 0. That is be called as a previous state. That means what the value happened in the previous state that will follows if both inputs are 0. Okay. Then the next state, that means for the current state will be the value previous value. Okay, here you can see the symbol of JK flip-flop. Here we have a three input, including clock pulse. I'm saying the clock pulse symbol represents about the positive edge trigger. If you are using a negative edge trigger, based on that symbol will change. And you have a two output. One is Q and another one is Q complement. This is the truth table for the JK flip-flop. Here you can see that here there are uh, uh, four states we are mentioning because we have a two inputs, so there will be a four state. If both inputs are 1 1, if one input is 1, another input is 0, if another input is 1, another input is 0, both inputs are 1 1, that's the conditions will be there. Okay, if you can say that here, if both inputs are 0 0, okay, if J is 0, K is 0, when the clock pulse raised to positive edge trigger, that time Qn plus 1 is equal to Qn. Here Qn plus 1 represents the next state and Qn represents the previous state. Uh, so you can see that if both inputs are 0, the next state or the output of the JK flip flop in this clock pulse is a Q1. That's the previous value. That means what's the previous value? It will follows if both inputs are 0, 0. Next one is if j is 0, k is 1. That's a condition. If j is 0, k is 1, that condition, your output is 0. Okay, j is equal to 0, k is equal to 1. In that time, the output is 0. Next one is j is equal to 1, k is equal to 0. In that condition, output is 1. Okay, j is equal to 1, k is equal to 0. In that condition, the output is 1. The final one is the updated format for the SR flip-flop. The undefined conditions were defining by using another method. This is called a toggle state. Okay. There is a toggle state will be present if both inputs are 1, 1. That means if both inputs are 1, 1, the output is the complement of last value. Okay, Qn complement. That means if 1, 1 is raised, if last value is 1, then here it is 0. If last value is 0, then here it is 1. So it will complement. If continuously you are giving 1, 1 in this JK, and every clock pulse, this values will complement. Okay, so this is the timing diagram. You can see here, there is a clock pulses around 8 clock pulses we have in this diagram, and this is your input. This is J and this is K. Consent Q and Q complement output are present. Okay, here you can see that J is 0, K is 0. The previous value is just present there. If J is 1, K is 0. Okay, if J is 1, K is 0, that time the Q output become 1 and Q complement is 0. That's usual because if this is the Q complement is the value of output, complement of output. So if Q is 1, the complement is 0. The next clock pulse again, checking the inputs. The input is 1, 1. That means it's a toggle condition. That means the complement of previous value. The previous value is 1. So here it is 0. Here the previous value is 0. So here it is 1. The next clock pulse, again, you can see that inputs are 1, 1. That means again it's a toggle condition. So that means previous complement of previous value. Previous value. This is the clock pulse. So the previous value is 0. So the output becomes 0. For the Q complement, 1 is the previous value. So it becomes 0. Again, you can see that both inputs are 0, 0 condition. Both inputs are 0, 0. That means that what is the previous value? It will follows. So previous value is 1. So it's continuing. Here it is 0. Here it is continuing. Here you can see that the next clock pulse also here the exact trigger time period only we are taking. So the exact trigger time period, both inputs are 0, 0. So the output again will continue the previous value. Previous value 1 is 1, so it will continue till the next clock pulse. In between the clock pulse, okay, not in the edge trigger, in between the clock pulse, the output is varying, but it will not change the value of output. It's only change in the time of exactly the Q. Here you can see that the seventh clock pulse, the input is 1 and both inputs are 1. That means toggle condition. The previous value is 1, so output is 0. Here the previous value is 0, the output is 1. In the eighth clock pulse, both inputs are again 1. So again I'm going for a toggle condition. 0 becomes 1, 1 becomes 0. Okay. So here you can see that based on the time diagram, wherever the toggle conditions are coming, that time the output is complementing the value. Whatever the previous value is complementing. Here it starts, here you can see in the third uh, edge to the pulse, both inputs are 1, 1, it start to complementing, it start to triggering based on the toggle pulse. Okay, so the output become 1 to 0, and the next clock pulse also both inputs are 1, 1, 0 become 1. Okay, 1 becomes 0. Here you can see that if both inputs are 0, 0, in that condition, whatever the output present in the past, that will continue. Here 1 was present, so it's continuing. Here also 1 was present. Here also one condition is there. Edge trigger happen that time both inputs are 0, 0. So here the output is follows the previous. In between the pulse, the input is changed that will not taken into count here. Okay, so I hope everyone understood about JK flip-flop. Thanks for listening to the topic. And that's all.